Hello everyone, we're going to talk today about functions, specifically about one-to-one functions, what they are and how to determine if a function is one-to-one, and also about inverse functions and what they are and how to find them. So let's start off with a one-to-one function. A function is one-to-one if, for each x in the domain of the function, there is exactly one y in the range, and no y in the range is the image of more than one x in the domain. So in other words, you think of it as for every value in the domain, so for every x, that matches with exactly one y, and vice versa. For every y in the range, it is the image and matches up with only one x value. A function is not one-to-one if two different elements in the domain correspond to the same element in the range. So here's a couple of mapping diagrams. The first one, in the upper left, you can see that every x1 goes to y1, x2 goes to y2, and x3 goes to y3. So they are matched up perfectly. That's an example of a one-to-one function. In the second one, the one on the right, x1 and x2 both go to the same y value. So therefore, that's not a one-to-one function. And down at the bottom, x1 goes to both y1 and y2, which you should remember from the previous video. That one's not even a function because the domain matches up with more than one in the range. So three different things to consider there. First, is it a function? If it is a function, is it a one-to-one function or not? So here's an example problem. So take a minute and think about this one. Is this a one-to-one function? Okay. The answer is no, it's not a one-to-one function, because the 13 in the range matches with more than one thing in the domain. The 3 goes to the 13 and the 4 goes to the 13. So they are not matched up perfectly, therefore it is not a one-to-one function. But it is a function because every x only has one y value matched with it. Now sometimes you'll be asked to determine if something is a one-to-one function based off of the graph. So you can picture the graph. Now we talked about vertical line test in the last video. You know that something is a function if it passes the vertical line test. Well, there's also a horizontal line test, and this one will tell us whether the function is one-to-one or not. So if horizontal lines intersect the graph of a function at one point, then it is one-to-one. So for example, here's the function 2x squared minus 5x plus 1. If we were to draw a horizontal line, and there it is, it intersects it twice. So therefore, it is not one-to-one. In this case, x cubed plus x minus 2, the horizontal lines only intersect one time. The top line only intersects once. The bottom line only intersects once. Therefore, it is a one-to-one function. So you use the vertical line test to determine whether something is a function or not. You use the horizontal line test to determine whether it's a one-to-one function. All right, that's all you need to know about one-to-ones. So now we're going to talk about finding the inverse of a function. You can find the inverse of a one-to-one function by switching the role of the x and the y. Now here's the definition of what a one-to-one function is. If we let f denote a one-to-one function, the inverse of f, which will be denoted by the f to the negative 1, is a function such that f to the negative 1 of f of x equals x for every x in the domain, and f of the inverse equals x for every x in the domain. So in other words, the top part I know is a little bit confusing, but if you look at the bottom part, if you put the inverse into the function, you should get an x out. And the same thing, if you put on the right-hand side, if you put the function into the inverse, you should get an x out. If both of those statements are true, the left side and the right side both have to be true. If they're both true, then we know that you have found the inverse, that these functions are inverses of each other. So you think of it as the inverse undoes the function. And since that's what's happening, it's undoing the function, the domain of the function will be the range of the inverse. And the range of the function will be the domain of the inverse. So you're switching the x and the y around. Therefore, you're switching the domain and the range around. So just You want to write that down. That's an important thing to make sure that you write down. The graph of a function and the graph of its inverse will be symmetric with respect to the line y equals x. Here's a picture of that. So the blue line is a function f. The red line is the inverse. And you can notice that these two things are symmetric around the line y equals x. And this is a true statement. This always happens for every one-to-one function and its inverse. They are always going to be symmetric around that green line. How do you find the inverse of a one-to-one function? Well, the first thing you want to do is you want to write the equation in the form y equals. Then we want to interchange the x and the y. We solve for y, and then don't forget to write f to the negative 1. You want to write it in function notation. So here's an example. We want to find the inverse of the function 5 over x minus 3. So for step 1, we're going to put a y in there. So y equals 5 over x minus 3. Interchange the x and the y. So notice what happened. I flipped the x and the y around. So the x is now on the left side and the y is now underneath. And then we're going to solve for y. So here's how we're going to do that. Here's our function. We're going to solve for y. So I'm going to multiply the y minus 3 across to the left-hand side. I'm going to distribute the x across. Now I'm going to move the 3x over, add 3x to both sides. And then finally I'm going to divide by x. So now I have y by itself, and then the last step is to switch it back into function notation. So f negative 1 of x, and then that's your final answer. That's the algebraic approach to finding an inverse. Another question that I might ask you on a test or a quiz is to verify whether these two things are in fact inverses. So remember how you test that. You have to put the g function into the f function and see if you get an x out. So we'll do that first. We'll put the g function into the f function. So I took the whole 5 over x minus 3. I'm going to put it into the f function. So I'm going to replace all the x's with 5 over x minus 3. Now I'm going to have to do some algebraic simplifying. So up top I multiplied 3 times 5. Found a common denominator for the 5. Distribute the 5 across. And you see what you get. And sure enough, that bottom one, 5 over x minus 3 on bottom, instead of dividing by 5 over x minus 3, I multiply by x minus 3 over 5, which causes the x minus 3's to cancel out. And then when you simplify on top, you wind up getting x. Now that's half of it. That's only half of it. We put the g into the f and we get an x out. Now we have to go the other direction. So now we have to put the f into the g. So we put the 3x plus 5 over x into the g function, which looks like that. Find a common denominator on bottom. Combine like terms on bottom. 5 divided by 5 over x equals x. So we get an x this way as well. So both times, whether you put the f into the g or you put the g into the f, you get x. That's a proof that shows these two functions are in fact inverses of each other.